So let's start today with LinkedList. So let me open. Okay, go to tutorial under data structure. There's a LinkedList. So first we'll cover this theory part, not question part, but theory part definitely will cover. Try to cover. So yeah, let's start with this. So basically in previous video we have seen the arrays, right? So this is the same thing, like extension of, you can say extension of array. So in array, that was like memory allocation happens continuous continue allocation, like suppose they want 5 integer to store in memory, and so that needs to be sequence, I mean to say. And otherwise, like suppose there is a 5 element store there, and just 2 elements store is blank there. So how are you gonna store? So for memory optimization, linked list is something has came, and that gives you flexibility. So whatever the blank, I mean, just suppose there is a only two element spaces remaining in memory. So that's how you optimize through these data structure. So internally this is how it works, but it's not like something, there is a completely different logic here. So basically let me explain this first. The data will be stored here, and it contains pointer as well. So there will be pointer to next node. So basically these data and next is one node, and these b is one node, and c is node, and subsequently. And the first element we call here head, and the last element always referred the it refer to null. Okay, so let me close this image. Okay, first we'll go through this statement. The linked list linear data structure in which we elements are not stored continuous memory allocation. So that's what I was trying to say. The allocation can be dynamic, so that's why this data structure is very powerful. The element in linked list are you link using. So basically how it gonna linked. So this is how the pointer location, like next allocation of memory, what is the address for that. So this link is something that will be referring the next element. Okay, let's suppose the first element stored here, and the second element, it's not necessary to next to that, it will store any other places as well. So linked lists internally work like that. In simple word, the linked list consists of nodes where each and every content the same I have explained. Let's go to singly. So this is the type of linked list. Okay, so basically this is single linked list, and there can be circular linked list, doubly linked list. So circular is nothing, this null pointing again to head, this is that called circular. And doubly linked list something like the both way. Okay, it will contain next pointer, I mean a next pointer will be b, and b previous pointer will be a. So this is something like you can traverse a to b and even b to a. Okay, let me explain first to completely singly linked list, then we'll come back subsequently. Okay, so okay, so let me open this. Okay, this is singly linked list introduction. What is the theory part we'll cover here. So as I explained, the same thing here they have covered in. And why linked list, this is necessary to know. Array can be used to store linear data of similar type. So as I said, like array is something you store subsequent, I mean memory. You use your I mean whenever you start allocating your memory, suppose first element stored on 0, so you just address would be +1. It's something like that. That's why called index base. And here index is not maintained. Instead of that, pointer they maintain. Okay, what is the next memory location? So that is what they are trying to say. But array has the following limitation: the size of the array is fixed. So basically, whenever you try to whenever you try to declare an array, you need to pass the array, what is the size of the array. So we must be upper limit and the number, that is what they are saying. And inserting the new element in array expensive. Okay, so basically what they are trying to say, suppose you have declared an array, and suppose you wanted to insert 1000 and in between 1005 you want to insert. So how you want to insert? So basically what you have to do, you have to create, basically you need to copy, okay, this is the 5 5. You need to declare one more array, that would be 6, and the one element extra you want wherever you want to put. So and these you can shift +1 location. So that's how you're gonna insert, right? So now, what is the advantage over array? Okay, what is the linked list advantage? So the basically size of the array, dynamic size. So there is no need, whenever I will show you what is the syntax of linked list declaration. But there is nothing like a size limitation you will face there. So you can add as many as node you want. You can insert easily, you can delete easily. Why here they are referring easy to insert and deletion? Suppose just you need to shift this pointer. Suppose you want to delete this b. Okay, so just what you will do, just this, the a next pointer will be referring the c. That's it. You're gonna lose this, you're gonna lose b. And suppose you want to, suppose yesterday you came, you want to insert new node. So just you refer the new node and new node next referring the b. That's it. The simple, right? Okay, coming back here. So drawback, what is drawback of this? So random access is not allowed. So in array what you do, like, okay, the first element and second element will be on first index, third index will subsequently is the index you can predict and you can fetch those elements. But here is nothing like that. You can't, you need to traverse those elements. Okay, you should start with head, and then you start with subsequent element, then you will get to know what is the address of the particular element. Okay, so extra memory space the pointer required to each. Okay, so here is the one extra memory we are occupying. Obviously next pointer will be addressing. So but in data is fine, data is similar to array, but the next element which referring to next b allocation, so that address is storing here, so that is extra, that is what they are referring. And the third part is not cache friendly. So since array elements are continuous locations, so there is a locality of reference which not in the case of it. That is what I explained. Okay, representation. So a linked list is represented by a pointer to the first node of the linked list. The first node is called head and linked list is empty. Okay, that is what if the, okay, so they are what they are saying, the first element if is there, that will be pointed with the head pointer. And if there is no element in linked list, then you can say the next element would be null, right? So each node in the list consists two parts, data and pointer. The pointer or reference, whatever you call the next node, the same terminology, you can use it. In C we represent node using a structure. So basically when you learn C, or you have gone through in college days, so they're the same thing in structure they have mentioned. and below is the example linked integer. Okay, in Java or C++, linked list can be represented a class or a node or separate class. The linked list class contains reference of node type. Okay, so what they are saying in Java or C has, you can represent this linked list as a class. Okay, but in C, when you will see so their structure, what they are declaring, and just they are defining, that's it. So this is how you declare even C plus when you will see. So that's where object oriented. So again, C class they have declared in Java also, in class, then node head. So node is nothing, just a class. Okay, so basically what they are doing, they are internally for linked list node, they are creating a node class, and they are putting the data where we will store the data and the node next. So node is nothing, just a class type. Okay, node is a class type which referring to next node. Okay, so and this is what the constructor. So just you need to just your data you are assigning, that's it, right? Yeah, I've explained in even array as well. So this is simple things, right? In Python, if you want to see the same thing, they in class, even in JavaScript they represent as a class. The same thing I almost each and every language. So let's stick on Java. Okay, four simple English in C using created 3 node. Let us create a simple linked list with 3 nodes. Okay, so what is this? So basically what they're trying to do, just a simple Java program to understand. So they are creating a linked list. Okay, a class, static class, which is a node. That is what I explained. Just data next, and then you are just assigning the default value or whatever. Whenever you creating new node, you are passing your data, and your automatically next will be null. Okay, so this is main class. You are creating an object of this class. Okay, outer class, linked list new node 1. So you are adding one node, second node, and third node. Okay, now 3 node has been allocated dynamically. We have referenced these blocks as head, uh, head and second and third. So same thing, like list dot head, we are referring here, and the second is okay. What now what we are doing, just the head next will be assigning to second, and second head next assigning to third we are doing. So same thing they have representing in picture. Okay, the first head will be this, and then second is this. So what we are doing here, just we are referring the next to second, and then we are referring second to third. So this is how linked list internally in memory it will be stored. Okay, so how you gonna traverse I mean, suppose in array just for loop you try to run and just extract all the values, but here how you will traverse the linked list. So that is the main point coming to this. So what they do, uh, print list, how they are printing, this is what I'm gonna explain, like how they are doing. So first they again created a node class. Okay, then just what they do, the same thing they have done, and they are assigning, and then they are printing. So once linked list created with these value, just they are trying to print those value. How you gonna print? Okay, so now while they have run the one condition, we know, right, the next node would be at last null. So till null we are printing n data, and n equal to n dot next. So that's what happening, like we are starting from head and we are reaching till null. So all will be printed, just we are printing n dot data, that's it. So the simple implication, we can even code that. I think better to understand once and try to code in ID or somewhere. So okay, important links. So I think this single link list we have completed. Coming to circular link list, how it works. So basically what I'll do, just advancement of single linked list. Just it's not at last element is not referring null, just instead of null, just they're again pointing out the first element, that means head. Okay, that's it. This is what the difference. So let's go through this. We have discussed single list, linked list, and the following. The circular. So linked list where all nodes are connected to the form circle. So this is node. Okay, so they are saying it's like circle. The last one, when you will draw in some different way, it is exactly look like circle. So there is no null, and at the end the circle. Okay, fine. Useful for implementation of queue. Unlike this implementation, we need to maintain two pointer for the front and rear. If we use circular linked list, we can maintain a pointer in the last element, and the front can be always the next to last. So they are saying the circular linked list we can use as a queue. You got, I mean, we'll understand later what is queue and all those things. Circular links are useful in application to repeatedly go around list. For example, when multiple application are running application, it is common for the operator to put the running application on a list and then to cycle through then giving each of them slices time to execute and then making another. Fine, just go through these are the basic fundamental of our OS. Circular list implemented advanced like Fibonacci. So these are advanced data structure will come through. And okay, so basically here what to do, this is the theory. And coming back to so how you wanna traverse that particular linked list. So let's go through this code and then you will understand what is this. Okay, function to print and give circular. So how you gonna print that list, that is what first they have explained, then they have written here. So first let's see, in singly linked list, or just you, nothing you need to do, that just you are doing like okay. But here what you have to give the condition, uh, if linked list is not empty, okay, and keep printing nodes till we reach the first node again. Okay, so here we need to just look up the head. Okay, this is what I was saying, the same way you can implement. And now coming complete program to demonstrate traverse, how completely traverse works. So here, this is how they have explained. Okay, so class, coming to node, function to insert a node at the beginning. So okay, so just they have destructured this program. Okay, suppose you want to push a node, and what is the data. So this is how you are doing. And function to print node and circular linked list to print the same thing like how I explained. And driver code. So first they are declaring a null with reference null, node they are declaring and reference null. Now they are creating the list. So head, that push they are doing, so now it will call this function, and we are giving the head reference and data. And what is the head reference? The same way, new node. Okay, now if linked list is not null, अगर if it is not null, then we need to move the next ref, and then we need to assign, else just directly assign it. So this is, you can go through this code once. I mean, you can write the code, then only you will understand. This is what you have: circular linked list coming to doubly linked list. So in doubly linked list, nothing much. As I told, like the pointer will be both side. Okay, so there will be like, okay, the pointer location, and then data, and then again pointer. So next pointer, previous pointer, both will work here. Okay, so how you gonna create a doubly linked list class? So just same thing, just you have to insert more, previous and next pointer we need to maintain. Okay, and constructor would be just data you are assigning to that. So advantage over single list. So here, the what is the advantage over single linked list? A DL can have both sides, as I said, like both pointer we have, the we can traverse in both direction. The deletion operation more efficient if pointer to the node or deletion is given. Okay, we can quickly insert a new node before given a node. And suppose, okay, this is what, nothing else. Adding a node, just go through, I think